Alrighty guys, so here's the continuation of the log functions, and so what we're going to do is we're really going to be able to see how these exponentials are truly the inverses, okay, of these logs. And to start things off, let's go ahead and do an example. Let's do f of x is equal to 6 to the x. Now of course we understand that f of x is treated like y, and so we can say y is equal to 6x, but now let's flip the x and the y. So I have x is equal to 6 to the y, right? Now, what we're going to do is we need to get the y out of the exponent. Now, in order to do that, remember we said that in order to get rid of a base of 6, we have to use a log base 6. So if I do the log base 6 of x on either side, we understand that these are going to simplify out, giving us log base 6 of x is equal to y. And so this right here is the inverse. And of course, remember, we like to write the inverse with the -1. It communicates to the reader that, hey, we're working with the inverse now. So both of which are acceptable ways of writing. Now, let's take a look at a natural log and how that's and how we do that one. So we've got f of x is equal to the ln of x plus 3. Once again, we switch it to y. And then we swap the x and the y. Now, of course, this is arguably some steps you may want to just simplify and move on to. You can definitely do that. I'm just showing everything in detail. Now, of course, in order to get rid of the ln, we have to remember it is with an e. So I'm going to raise everything to with an e, with a base of e, and put everything to the power. So I've got this now. So I've got e to the ln of y plus 3, so the ln and the e will simplify, and I have e to the x is equal to y plus 3. Now the y is not by itself just yet. I need to go ahead and subtract the 3 on over, leaving me with e to the x minus 3 is equal to y. Now of course that is the inverse, but we typically like to write the inverse as this, e to the x minus 3. Now be careful, this minus 3 is not in the exponent. Be very careful of that, okay? I've seen a lot of students make that casual mistake. Now we could also do an additional example. Let's try this one on for size. And let's do f of x is equal to 4x, 4 to the x. And so to go ahead and simplify that, you got y is equal to this, and then we got x is equal to 4y. Now what gets rid of a base of 4? Well, a log 4, okay? Log base 4 does. So I've got log base 4 of 4 to the x. These simplify out, and you've got, oh, sorry, this was supposed to be a y. I got carried away there. So we got y, and then I've got log base, back up more. Log base 4 of x is equal to y. Okay, there we go, back on track. Now, of course, you can say f to the -1 of x is equal to that as well, okay? Now, let's do a natural log, another one of those. So, doing a natural log, I've got the f of x is equal to the ln of x minus 5. So, I've got y is equal to that. Now flip x and y. Now raise it to the power of e, right? Or raise it with the power of e. And so we have e to the x, and we have e to the ln of y minus 5. So that's going to give me e to the x is equal to y minus 5. Add 5 to the other side, so you have e to the x is plus 5 is equal to y. Alright, so that right there is hopefully a nice little introduction into how we handle those types of problems. If you need anything else, please let me know. I'll answer more questions. Other than that, thanks for tuning in.